Hey everyone, welcome and thank you for joining. I am John Howard, a software engineer at Google and a maintainer of Istio for the past couple of years. And today I wanted to talk about how the Istio community has been working with Kubernetes to standardize some of the APIs and functionality that Istio depends on and kind of bringing them to Kubernetes and what benefits that will bring to Istio and kind of the broader Kubernetes community. So one of the key things we're going to be talking about today is this new API coming from Kubernetes called the Gateway API, not to be confused with the Istio Gateway API. And we're going to talk about kind of what this API is, why we need it, what it's going to do for Istio, and kind of what our plans are for the future. We'll kind of do a deep dive into that, and then we'll kind of briefly discuss some other areas that we're working on aligning with Kubernetes, including multi-cluster, some more native sidecar support, and some more native mutual TLS support in Kubernetes as well. So before we get into that, I want to discuss a bit about where the Kubernetes networking APIs are at today, specifically with regards to kind of ingress traffic. That is traffic coming from outside of the cluster into the cluster. So Kubernetes has provided this ingress resource to do this since the very, very early days of Kubernetes. And what this allows us to do is, like in this example here, do things like I want to match on the hello path and send to the hello world service. And this API I think is great. It's very simple, so it's easy to understand, easy to get started, and that's something great to be said about an API. And it's also very vendor neutral. So Kubernetes provides the API, but there's no standardized implementation. Instead, there's many different implementations that have various different features, performance implications, etc. So Istio is, of course, one of those. We implement the ingress resource. There's also many others, such as Nginx ingress. I think there's some HA proxy ones, etc. So there's this vast ecosystem around this API. But some of the good things about the API are also the bad things about it. So while it is simple, it is oftentimes too simple. So for ingress needs, there's a lot of different things we want. We want telemetry. We want different security policies. We want much richer traffic routing than the API provides. Because the API is so simple, there's no way to do that. And so what happens is that all these different implementations have come up with a bunch of different ways to extend the API. So for example, Nginx ingress comes with a host of different annotations to configure all sorts of different things. And this is great because now you can configure all these features you want, but it's also hard to manage because all these annotations, you have to remember, there's no schema anymore. The validation is not as strong. The documentation may be harder to understand. The typing, it's all a string, so there's no longer these rich structures like we have in ingress. And overall, it's just kind of a worse experience to put everything in annotations rather than having a first-class resource in the API. So the path that some other projects, including Istio, went down is to instead replace ingress with other first-class Istio or Kubernetes resources. So in Istio, we encourage to configure ingress traffic using the gateway and virtual service APIs. So there's a lot of good things about these APIs, I think. Two of the most important ones is that it's highly expressive and customizable. So this virtual service here, for example, shows that we're doing a header match on an arbitrary header, which is something you can't do in the ingress API. That's just one very small example. If you go through the documentation, you can see there's probably 100 different fields of all sorts of different routing customizations you can apply. So there's this huge, rich feature set to support almost any use case possible. And something that's very important at Istio is that we have one consistent API, and we use that both for the mesh and for the ingress traffic. Whereas generally the ingress resource is only about configuring ingress, so it's a bit too narrowly scoped for Istio. Where things start to get kind of worse with our own API is we lack some of the ecosystem integrations. So we do have some support in things like Cert Manager and external DNS, but you're much less likely to go deploy some off-the-shelf Helm chart for a random application and see a virtual service being created than you would like an ingress resource being created. And along with that, there's also blogs, documentation, examples out there, and there's much more of those for ingress because it's part of the core Kubernetes than there are for virtual services. And we also have minimal interoperability with other implementations because most other products are not using Istio native APIs directly. It's mostly Istio implementing this rather than Ingress, which is implemented by almost everyone. To kind of solve all these issues, the Kubernetes community has been working closely with Istio as well as a number of other Ingress providers on creating a new API that we call the Gateway API. It does happen to have the same name as the Istio one, but it is a distinct resource, so I'll try to avoid confusion with the naming there. So the idea here is we want to take the learnings from all the different Ingress controllers and kind of apply those to a new API that will be part of Kubernetes ecosystem, whether that's in the core Kubernetes or Kubernetes official CRD. And that way we'll have, once again, have a common API that's shared amongst everyone, but we won't have the problem that it's kind of this lowest common denominator, too simple for most use cases like Ingress. So the API is highly designed around the concept of extensibility. So we know that Istio will always have features that are implemented only by Istio or a few other products. So it doesn't make sense to put them in the core API when most others can't implement them. But we need a way to allow Istio to still offer those functionalities. And so there's been a lot of work put into the API on this concept of extensions and how we can kind of lower the bar for how to apply custom features and other things that Istio needs and other products need. We'll go into that a bit more later. So kind of a high-level overview of the API. If you look closely, you'll see that it's very, very similar to Istio. That's somewhat by design, and kind of why we're one of the reasons we like the API so much is that it's brings a lot of the benefits that Istio API has brought, but it brings them kind of to the mainstream Kubernetes. So just like Istio, there's this resource called a gateway, which sets up kind of the higher level load balancer. You can do things like, I want to open a port, I want to serve this TLS certificate, etc. And then you can bring in routes from a bunch of different namespaces, which could be controlled by different users, perhaps. So for example, I may have one application team that owns the foo service, and they can say, when I hit foo.example.com, go to my foo service and apply this header manipulation rule, these logging rules, the security policy, etc. The bar namespace can make their own bar route and apply whatever rules they want, and they kind of all join together in the gateway. So I want to highlight specifically kind of a side-by-side of these new resources and the Istio ones. So this example, I have a Kubernetes gateway and an Istio gateway, and they're both doing the same thing, that is exposing the domain.example over port 80, and we're declaring this to be HTTP traffic. So while the shape of the API is slightly different, the minor syntactical differences, they are largely doing the same thing. Similarly, with the routing API, once again, very similar. We, on both rules, on both sides, we have like a matching on a URL. We can route to destinations with some weighting on which destination we go to, etc. So a lot of the functionality that's in Istio will become part of the core Kubernetes APIs. So going into how Istio is planning to implement this, one of our goals is that all of the rich functionality that Istio offers today will still be expressible with the new API. So not everything in the core, not all of the Istio features will be in the core API, of course. We offer a lot of features, and many of these are things that are not or cannot be offered by all other implementations today, just due to various limitations or, yeah. So we will have instead extensions. And I'll dive a bit more deep right after this on kind of what those extensions are. The other important thing is that we're going to have interoperability with Istio resources and the Kubernetes Gateway API. So we really don't want to create these kind of two walled gardens where like you have either your Istio resources or you have your Kubernetes Gateway API resources. We want them to all be able to be mixed in a cluster so you can kind of seamlessly move over. If you're kind of following some documentation that uses the old Istio ones, you can continue to use those even if you have Kubernetes Gateway resources. And so that way it's really easy to kind of migrate over, and you don't need to boil the ocean and move everything over at once. We're also hoping to have kind of tooling to help migrate for users that just want to move everything over. So I talked a lot about extensibility, and I wanted to show kind of two examples of how that will work. So in Istio today, a lot of the configuration has kind of this implicit composition. So here I have a destination rule, and I'm saying the host is hello world, and I want to apply some load balancing policy. And somewhere else, I may have a route that sends traffic to hello world. And so there's no explicit linking between these two resources, but Istio is able to figure out that, hey, the hello world in the destination rule and the hello world in the HTTP route kind of mean the same thing. So when traffic goes through this route, I'll apply this load balancing policy, and we'll get the end result that we expect. So we talked a bit about how we want Istio resources to be interoperable. So this will be very common for that reason. But the approach that the API is encouraging is instead a more explicit composition. And so instead of having that explicit or implicit match on hostname, the policy, which here is a destination rule, but could be anything that is kind of impacting the traffic. So it could be a telemetry policy, a security policy, a routing policy, etc. They will all have a common way to attach to various locations. So in this example, we say we have a target ref, and we say this destination rule should attach to the HTTP route that is named route. And so we're kind of explicitly pointing to this HTTP route. And the cool thing about this is that, one, it's a lot more explicit. So it's easier to tell what exactly we're trying to do. And in fact, we can even have tools that kind of display a graph of the policy tree if things get very complicated. And the other thing is that it can be common across different implementations. So while Istio may have destination rule, which is like an Istio-specific CRD, there may be some Nginx timeout policy, for example, and they'll have the exact same target ref API. And so even in the extensions, which are totally custom per vendor, there'll be a common way to express how things are attached. So I want to caveat that the API is still an alpha. So everything we've discussed so far is kind of tentative. It's very subject to change. Actually, the previous slides I had to change a few hours ago because of a new API or new PR that was merged into the API. So things are rapidly iterating and improving. However, this does present a great opportunity to get your feet wet and try out the API now, as we're very open to feedback right now and can make any changes that are needed to meet users' needs. So I highly encourage you to try it out. Istio offers support today, so you can try out the earlier versions of the API and see how you like it, if there's any issues, etc. That being said, our optimistic long-term goal is that these APIs will become the stable networking APIs for Istio. So I want to avoid the word replace because that makes it sound like the old ones are going away. We're not necessarily replacing, more as augmenting, similar to how Kubernetes is adding these new APIs, but the Ingress API is not going to be removed. So we know that there's hundreds of thousands of virtual services, gateways, destination rules, et cetera, that are out there in the wild across thousands and thousands of clusters. And there's no way like all of those are going to just migrate over to the new API, not in the short term and probably not in the long term. So our intention is that these will stick around. And while we may encourage the gateway API, and that may be kind of the recommended documented path forward, the old ones will still work. And as previously mentioned, there'll be some interoperability between those. So you don't have to kind of do this hard migration over. So yeah, I am super excited about this API. Hopefully you are too. And like I said, please try it out. Give us any feedback to Istio or the Kubernetes community. And we're always happy to hear how users are using Ingress. So shifting gears a bit, I want to talk a bit about multi-cluster. So Istio has, from some of the early days, supported a mesh spanning multiple clusters. And because there wasn't that much usage of this concept of like multi-cluster beyond Istio, we kind of had to figure out a lot of things ourselves. And since then, a lot of other products have done much of the same things. So there's probably 10 different products and 12 different ways that multi-cluster are implemented. And so Kubernetes kind of saw this and wanted to come up with a standardized way to represent multi-cluster service discovery. and they came up with an API that is aptly named the Multicluster Service Discovery API. So we've been working with their community on this API to make sure that it meets our needs and that we're able to implement it and support it. And so we're pretty excited about what this will do for multi-cluster. Just a brief overview of the API. It kind of revolves around these two core components. One is the service export, which essentially just says this service is accessible to all other clusters in the cluster set. Cluster set is kind of the name that they've given for a group of clusters that are all joined together. So in this example, we have the ratings service export, and that means that the rating service should be exported to all clusters. And the magic kind of happens from what is called a multi-cluster service discovery controller, which will read these exports and create these service imports in all the joined clusters. So once this happens, DNS is set up, there's IPs reserved for it, and now clients can seamlessly call services across the whole cluster set. Once again, this is an early alpha API, but there's been a lot of investment from Istio as well as other projects on bringing this support to Kubernetes. So I'm very excited to see this play out. One other thing that we've been working on is kind of more native Sidecar support. So today, Kubernetes supports multiple containers in a pod, but there's not really any relationship between them. So in an ideal world, we would have like Istio is always running when the application pod is running. That way, there's always connectivity from the pod. But what happens in reality today is that when a pod starts up, there's essentially a race between the application pod and Istio. And if the application starts up first, then it may not have network connectivity for the first few seconds while Istio is still starting up. So I've included here some snippets of the top Istio issue and the top Kubernetes issue. They're really both the same. They're both about this concept. And so there's been a lot of desire to kind of improve the situation in Kubernetes from both sides, really, from the Istio and the Kubernetes community, as well as from other service meshes. It has unfortunately been a very technically challenging problem. So it's been a kind of long-standing project that we've been working on for the past couple of years, but we're still kind of working on this, pushing forward with the SIG-Node team on Kubernetes on how we can kind of meet these needs and improve things in Kubernetes itself that will help Istio. So we're short on time, so I can't go deep into this one. This is much earlier than the other ones. It's actually not even a fully approved KEP, which stands for Kubernetes Enhancement Proposal, but it's kind of in the early design phases. But I think it's pretty exciting for Istio, so I want to share it. So I've been looking into this idea of adding first-class support for managing mTLS certificates in Kubernetes. So what this would mean is that when a pod starts up, if it's configured to do so, it will automatically get an mTLS certificate. Kubernetes will handle rotating it, revoking it, etc. And what that means is that Istio can get out of the business of managing certificates. It can just ask Kubernetes to give us one, and we kind of reduce a lot of the operational burden of Istio. Thank you. I hope you enjoyed getting a glimpse of what Istio has been working on with the Kubernetes community, and feel free to ask any questions and give feedback. Thanks.